Hey there, Derek. How's it going today?
Hey, pretty good. I was just running around seeing if I could get some stuff updated for that mirror one before, but need to update that definition. I didn't realize we don't actually have even a definition of repository in the spec.
Yeah,
I
that was
think
on
I
purpose.
I tried to add
I
one
tried a
and
couple of times. It failed, Derek.
I'll say it again.
I tried to put it in a couple of
Oh
times, and
yeah.
it was decided at the time that we should not define it.
Yeah, Brand, you said you tried to.
yeah, I tried to put it in and Mike vetoed it.
Yeah. Uh,
Was it me? Jeez, I could have swore I put it in. You vetoed it. I don't know. I'll have to
maybe
look
we
it up.
can try to come up with like a I mean, I guess it's weird because it's mentioned all over the spec because it's a key part of the URL, but we don't really define what it is. And I think for the mirroring, we kind of have to define it.
We talked about putting together a work group around namespacing at one point in time, and I think that was the. I'm trying to remember that might have been the limitation.
yeah, I don't want to get bogged down too much though in like full name spacing, but just at least defining what the parts in the URL represent, um, or in the requests without getting into what format it should be in or anything. I mean, I guess right now the format is kind of limited to the URL format, which I think is good enough for us to start, or just
Yeah.
leave it at that. At least in the distribution spec, we just don't need to care.
Well, did we? Yeah, I think even on that, I guess you could isolate out the namespace, and then we good with that. Um, the right hand side. I don't know.
Yeah, I was trying to say there's the namespace within the registry, and then I was using words related to everything else we're doing in the spec, and so the bracket name syntax that we put everywhere.
I think I actually tried to give it a definition, so it wasn't necessarily just me saying no.
Yeah, I don't think I can fit all this in the top section. That was my challenge. I was looking for how we can get a little more concise than a paragraph because
Okay. Well, we can read
everything else up there is just like a little quick one-line sentence.
Yeah, that's the tricky part, is boiling it down into something concise. I mean, that
Mhm.
seems pretty good. I think the thing that's added with the proxy is like, yeah, the problem is this isn't what runtimes use. Like, to a runtime, the image repository name includes the domain. So we'd love to keep it super simple, but without trying to paint it into a corner in terms of what it is, or getting into the image naming uh, debate.
And in case it wasn't clear from my earlier comment, Mike,
Scroll
I
down
was
just a
just
hair. Let's see what the suggested change was.
yeah, I
22. I don't remember.
I was just giving you a hard time when I was like, Mike vetoed it. I'm like,
Oh, okay. I'm like, wait a minute, did I do that? No. I can't remember things I say years back.
it yeah, it's been sitting out there for a long while. We never got around to figuring out the right way to clean it up.
Oh, that was interesting, Derek, you mentioning that you could actually just remove the in registry.
In a whole lot of places,
Right.
where it's saying, hey, the manifest's not found in the registry, just strip that sentence out, and I could do that too. I think it's still good to have a definition at the top of the file, though.
Yeah, we definitely need a definition at the top of the file. I didn't realize that we didn't even have one. I was looking up there to like, oh, maybe I'll see if I can easily update this. I'm like, oh shoot, it's not even, we don't even define it, which is kind of
I almost want to say it's par
I
for the
can-
course for us.
It's a string. Just leave it at that. A string value.
I don't disagree.
I mean, I guess it kind of inherently is a limited by what you can put in a URL, but I don't know. Like that's doesn't say much.
I still think we could at least do some basic namespace kind of thing where, you know, it's a part of the string on the query that is isolated to the um, the connection that you make with the registry, um, defined by that connection, I guess you could say. Because I mean, what is colon? What's the slash root? Is it /0 whatever for Docker's default?
Default is /library.
/library. Okay.
Mm-hmm. For the official images. I was also going to point out we do have on the agenda, I had it later on, but some sane limits on the repository name. And I think there was a request that, hey, can we limit this to only 255 characters on the repository name? And that some other groups have some limits somewhere. And I wasn't sure how we wanted to handle
sounds
this
familiar.
because
Yeah.
I wasn't sure how we want to handle this because it gets into individual registries have limitations versus should the spec have a limitation. I don't know that we want to make the spec have a limitation because an individual repository does. Like a lot of registries out there only have 2 levels of namespace. Doesn't mean that some other registry couldn't do more. And similar with the number of characters, I feel like there are going to be some registries out there that can have more.
I mean, right now it's a domain, right? So
After the domain, this was the repository name itself, but it may also include the domain in certain scenarios.
Is there any real limit on just URL definitions, or is that like 65K or something crazy large anyways?
I would not be surprised at something crazy large. All right, well, we're a few minutes after. We kind of did a soft start here chatting about some other stuff. Do we want to skip back real quick to image spec? Because I know Sajay usually has to duck out a little early. So on image spec, I did put out there, and did I even turn my video on? I'll work on that in a second here. I put in that we still have this one sitting out there, JSON schema, the switch to the library on that one. If we get one more review, conveniently, Sajay, hint, hint. This one is a fairly big change in terms of what's happening in the code, but I think overall it's going to be a nice change in that we're stripping out a bunch of stuff we don't want. We don't need YAML parsers that are out of date and have vulnerabilities in them and stuff like that in there. And then there's other changes in terms of just files we're able to completely delete to make this a lot cleaner. So something to look at, double check. I don't think a lot of people are calling this code. And then once we do that, then I can go through, there's another change that we were talking about last week to tweak a few things. So getting that one back visible again.
Can you get a release tag for this one too? Since like that will affect, like if you're simplifying some of the imports,
we want
some
to
of
pull it like a patch release.
Yeah, because if that cleans up the dependency tree of everybody importing, that'd be nice.
Yeah. Yeah, I wouldn't mind doing that. It's always good to exercise that muscle too. So that would be good to do. I see thumbs up from Sajay, so I think that's all I need to get that one done. The other one we skipped on last week. We ran out of time, but I think Rom wanted to chat about some of the large images and maybe EROFS. So I threw that on there in case, Rom, you wanted to spend a little bit of time this week chatting about it.
Yeah, so I was actually playing around with so the requirement, the problem statement is, yes, we have this, at least from the AML community, that this requirement is coming from, maybe others too, that we have this very large artifacts, and uh, the way these artifacts are built are, if you have an AML model, then it's probably just one or two files, maybe a data file followed by the model weights followed by some other metadata packaged into one. So if you did that as a your restart GZ, Sochi, and all of that stuff, I don't know how much of a benefit you're going to get, because they're just single files. So in the dist spec, you can look at the PR. The thing was basically try to parallelize within a very large layer, and it seems like there's a bit of gains that you can have there. In this particular change, what we're exploring is, instead of constructing these things as star.gz layers, can we actually make them read-only compressed file system layers, such as squashfs or erofs? So what it would look like is, let me share the screen. Just some workspace. So I just built ignore all the, so we have a tool here that does some cool things, but ignore that for a while, right? So the way this is, we have 3 layers that are being built. One is built from empty, and I have rootfs which contains busybox, and therefore I put it at root. The second layer derives from layer 1. It does a bunch of creates and things like that. And a third layer in which you actually delete a particular file. This was because there was one question about whiteouts and such, right? So what this will do is, when you build this thing, what it will do is it creates an OCI layout, like so, which is just a regular OCI image. And if you take a look at the actual image, it has 3 layers. And the nice thing is, it is all of these layers are squashfs, ESTD, Verity, DM Verity kind layers, which is done like this. Now, I guess what I'm proposing here is, eventually, if this work is mainstream, then this becomes another standard image format. But that's a TBD. So now we have these 3 layers. Now let's mount them. So since they're squashfs, so what I'm simulating is, I have pulled the images. Now, instead of unpacking the images, I'll just go ahead and mount them, right? So there is no unpack because these are not tar layers. So let me mount. So that is the first mount. So this is the part where we skip the unzip, either through direct unzip, or I mean the gunzip, right? Or through your all the various techniques that you have. So this is the second one, and this is the third one. Oh, what's that? So these are the 3 layers that are mounted. So now if you say tree SQ1, so this was the first layer which had a busybox root file system, because we were building from scratch. We need a shell. This one is where we created the directory and we created those 2 files. And the third one where we actually deleted the file, and there is your whiteout right there. Okay. So just to show that this maps to that, it is exactly like this. Okay, so now that we have all these layers mounted, then what we do is we just do overlay fs on this, right? So we do blah, 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 upper dir, lower dir. I hope I got the syntax right. Okay. And And there you go. And that's it. So now once you're set this up, then you just pivot route into this and you have your container just seeing this file system. So what I have demonstrated here is if you're able to package your layers as a different format, then you get you will take advantage of the ability to pull a single layer in parallel using the disk spec PR that I had. And the second thing that is being demonstrated here is there is no tar gun zip either via fuse or whatever. You just go ahead and mount these layers and pivot route to it, and then you're done.
So what was the process to build that layer?
Oh yeah, there is a binary call it. That's what. So
Is
this is a
like
tool that I didn't want
library?
to.
Is that part of a Go library that you're calling to do that generation?
No. Yes. So the stacker is a tool. It's a public project. We just submitted to CNCF. You can go ahead and take a look at it. But yeah, so this is a it's doing things what lot of the tools are already doing. Umochi, Podman, a lot of these things are doing that. We are doing is we're just making sure that it is just OCI and it is doing a few more file systems that we were interested in.
Yeah, the part that I'm trying to be careful of is I want to make sure that it doesn't require a root to be able to generate it. Like you're not
No,
making
it's
a
not.
temporary mount.
It's completely rootless. This is a rootless build.
Okay.
Yeah. So now, so this is now. If you look at this, I didn't do the squashfs generation. I did the tar.gz generation, which is the default, right? So if you want to. If you want to build it like this, it will be that's what you do, right? So this creates a squashfs layer, and I'm actually going to add something like that in AeroFS layers. So what does it mean, right? So assuming that this is of interest, then in containerd, what you would do is instead of I was actually looking at the containerd code to try to put a patch in there. The code is quite massive. I'm just trying to grok that code. So what we are looking for is you want a place where you pull the layer. Once you pull the layer, and of course the pulling part we make it parallel within a layer, and then the second part in containerd is you want to just mount these as squashfs, and then you do an overlay mode as usual and pivot route. That's it. There is no unzip, no untar, no other machinery needed. Just the change in the media type will achieve all this.
How much of the unzip in general today is a performance issue versus the network, and is the unzip an issue just because of the way we coded it? Like, could you
let me give some numbers, right? Let's see. So you have one file which is about. So if you take the Meta Llama 3, their largest model, they're still training the newer one, but the one that is released is about 140 gig, a single file.
So the direction I was going with that is, could you, instead of coding things right now where it is very chunked and serial and iterative, could you change the pull of that layer? Because I think the biggest chunk of time here is the network traffic here.
But once it comes down, it is. Oh, sorry.
If you're doing both if you do them serial, you're going to see that big long lag at the end after you do that big long download, and then you serially do that untar. If you did it in parallel or just in a pipe where one goes after the other, you could unpack that tar on the fly as it's being downloaded, and I don't think you'd see the same lag at the end of that. And so I'm wondering if this is something where if we just change the order of that, we could get better performance, and then we wouldn't have to completely redesign the underlying image.
Yeah, so that's another option. So what you're suggesting is make the Sochi index as a part of the spec itself in a way, so that when you're pulling a single layer, you want to pull and unzip the pieces that you're pulling in parallel.
I would go not even to Sochi, but just in the direct tar layer of just instead of making it an iterative operation, where things are chunked up into batches, just have the download pipe directly into the unpack, and then that would have the file system unpacked as soon as that layer is finished downloading, or within a microsecond. Am I
So if
completely
you no,
off track with that? I'm looking toward like Derek and Mike on this one in terms of some of the underlyings of Containerd.
Well, okay, so there's a few things here. One, if we have an image like this, I think it'd be great. Like, because there's a lot of stuff we could do on the lazy side if the format is directly mountable. It's then it's just a matter of like you can use something like the a SCSI mount or something to just make the block device, pull the block device in the background, and then you can mount it right away. And then pull all the data in the background in parallel, whatever. That's assuming we have this format that ROM is proposing, which I think we should do. I think we should have the option to just have images directly export these types. I think it makes more sense in the long run. In terms of compatibility, there's the AeroFS maintainers mentioning that they also have a tar to AeroFS utility as well, where you could potentially just, if your snapshotter in the Containerd world, your snapshotter is AeroFS, you could just pull down the tars directly, create the AeroFS block file for the snapshotter. If you have the AeroFS directly in the image configuration, I mean, that makes it really simple. Like there's a lot of ways we can optimize it if we already have this to do it in parallel and lazily.
I still need to spend some time debugging the AeroFS or
And we are missing a few primitives in Containerd today to make this possible that we are working on actually. One of them is around the mounts when you have block files, you want to mount multiple block files and overlay them. That's something that we're working on. We'll have an interface to do that from the snapshotter. Because right now it's kind of ugly because you have a bunch of block files and then the snapshotter has to mount those block files, but they're not tied to the life cycle of any mount. So you end up consuming a lot of resources just to keep these loopback files around that aren't potentially not even mounted. The second is around the difference between if you have a block file like Rom showed, where does that block file live? Does it live in the content store? Does it live in the snapshotter? If we want to have an interface where the snapshotter can basically pull stuff directly from the content store, and that could be lazily loaded from the registry. Because today we have in Containerd, we have two different IDs essentially. We have the tar ID, which is in the content store, and it's very strictly hashed and validated. And then we have the snapshotter, which is unpacked, the unpacked version, which basically that ID is created locally based on when we verify the rootfs ID, but that's not actually what was transmitted over the wire. That was a result of doing the unpack and what we saw during that unpack phase. Whereas if there's no unpack, the identifiers kind of become simpler, but we don't want to do like an extra copy. Like I want to copy everything down into the content store, like syncing everything from the registry, and now I want to copy that into another place so that we have a snapshot. Like ideally, there's just one file. And in the case where you're doing it lazily, there's maybe not even a file locally. It's just pulling it down when it's needed.
Is it possible in Containerd to change from the iterative process to something that's more of a streaming process?
I mean, we have lazy loading snapshotters today, but they rely on like Sochi or EastarGZ. They rely on pulling in a manifest up front.
I might be using bad terminology for this. The thought process I'm thinking of is when you start to pull from the registry instead of waiting for that entire pull to finish and then trigger off a untar and, you know, a gzip extract and that kind of stuff. If you could just pipe the download directly into the untar as it's being downloaded on the network. Maybe it already does that today and it's only a Dockerism that I'm used to seeing, but I'm used to seeing from Docker when you do the pull of an image, you're waiting for previous layers to finish downloading, you're waiting for the download to finish, and then a whole untar extraction process kick off.
So in Containerd, there's two different ways. One is if we have like an optimized version for overlay specifically, because for overlay you can unpack. Well, we still don't do it. We can do it without mounting, but you can't do it in parallel because of the way tar works. You might be stuck in a situation where you have a file that doesn't have its parent directories defined. So you actually end up needing the parent directories to exist first in order to get the correct permissions from the parent directories. Otherwise, you might default and then overwrite the permissions. And that's a weird tar issue. We don't have this issue with ArrowFS or SquashFS because it's actually a file system with, like, you can't have anything that's undefined in it. So you would copy up the previous layers. But currently today in the tar format, you cannot guarantee that the parent directories for a file exists. Therefore, you cannot just create that in a layer that potentially clobbers the parents. So we have to do that in order. But we do them, like in Containerd, there is a way to do it in an isolated way if you're unpacking to overlay, where you don't actually need to mount. But there is a condition where you might have to look at the parent directories in order to get the correct file permissions, parent directory permissions.
So I'm trying to think through the logic on that. If you ran the untar and it said create this file and the parent directory didn't exist and you just create it with a 755 permission or something like that, and then later on in the untar you saw that you were extracting that directory with permissions, couldn't you just change permissions on the directory? Or
I mean, saw where, when, who's the parent of who. If you just treat everything as like parallel, they're not necessarily knowing like, hey, I just saw this file in this other parallel process. Like, so at that point you're ordering the process anyways.
So it would be a parallel download of multiple layers, but I'm looking at the concurrent as I'm extracting a tar. I'm going to extract it straight from the network. Don't wait for the network to fully download to a temporary file and then kicked off the process that says, let me now unzip this thing and go. You just pass a reader to the next chain of the process and just kick it off there.
The other issue with that is tar bombs and stuff like that. There's a reason why we verify the hash before, because if you got man in the middle, you can inject a lot of stuff that the untar process is not going to handle very well, compression bombs and stuff like that. So like it does, if you do not check the hash before you start the unpack, it does make your system a little bit vulnerable to a denial of service attack.
I mean, you could still have a tar bomb with a valid digest. We're just saying that the tar bomb from a man in the middle kind of attack you would be preventing.
Yeah, but I mean that's just saying don't pull images you don't trust. Like if it's just a bad image, that's an operator problem. But if it's a man in the middle attack, then that's another problem. Which actually is a relevant topic for this, because in Rom's example, we're pulling the whole thing and then mounting it. But to do lazy loading, there is a case where maybe the digest isn't, maybe just a single digest isn't what we want. We want a list of chunks and those digests of those chunks, and then have the digest actually be a manifest of different chunks so that we can actually pull stuff securely in parallel. So that's kind of what you get with like Sochi and eStarGZ that we would lose in this world where, hey, now we just have this massive 1 GB file. And I have no way to verify that hash until I've downloaded 1 GB worth of data, which is, yeah.
Thinking back to the scenario though, where you're saying you're worried about zip bombs and things, tar bombs, things along those lines. I wonder how much that can be mitigated by having extra metadata that just says, sure, here is my compressed size. The uncompressed size should not exceed this, or it's going to exactly be this kind of situation. So that way, if you're uncompressing and extracting this onto the file system, you would know, hey, I've exceeded whatever my expected limit is, just as if you were starting to pull a digest in, the digest kept going past the end of the size limit, you can say, you know what, my size limit told me I was only supposed to have this many bytes on the network. I'm done.
I mean, that's kind of what Sochi and eStarGZ do. Like they have that extra data that tells you that, so that you don't have to pull everything up front.
But I'm wondering if we can get some of that extra data. I mean, the direction I'm going back to is originally we were thinking of doing transport level compression. In that case, your decompression step, you would know the exact size of the decompressed file at that point. And we just don't have that today when we only have the descriptor with the compressed data.
Yeah, that is something we're missing. I agree. But yeah, I think if we get away from, well, Ram, in your example, can you go back to the media types you were proposing there? Whether or not I saw the Z standard compression there. My understanding, maybe I'm wrong here, but if it's AeroFS, we can do inline compression, so we don't need to have a compressed blob. Does the SquashFS give us something like that, or do you have to compress it at the end?
Right now you're compressing it at the end and adding a DM verity on it for block level verification. But EuroFS, you're right. I think it could be in inline compression. I have to take a look at the details. Once I start coding up that patch, maybe over the weekend, I'll know more.
I'll add a tiny nit onto those media types, which is that I think you're only supposed to have a single plus, aren't you?
It's a prototype.
Yeah.
Where's the verity information at in this case?
It will be at the end of the blob, at the very end.
Okay, is that built into SquashFS, or is that used by your tool?
So
okay.
This tool is actually taking the library, but the idea is you can, when you make the DM verity, you can say, hey, this is a hash of a set of hashes, and it is located at this offset. So you first create the file system, and then you add the DM verity at the end. So just to call out, right? And none of these ideas are super original. So Alexa has been talking about OCI V2 a long time. He's been beating down on tar for a long time. And the first iteration of this was done by Tycho, right? Now is it? So now I am the owner of this tool. But yeah. But the main idea is this, that if you change the media type from a tar.gz into an actual file system, then you get rid of all this file system headaches that we have with tar. Apart from the not requiring to unzip anything. And this also takes care of all the lazy loading and all that stuff internally. So there you go. That's the additional benefit.
Yeah. One of the comments was about there's there's already a media type that exists for SquashFS and ArrowFS?
Not for SquashFS, for EROFS. You're right.
Oh,
So for
okay.
EROFS, there is already a layer, but remember so the argument that Brandon was making was, yeah, OCI doesn't really care about what you put in here. You can do whatever you want, right? As long as this is correct. So this one, right? So this is correct. So so what I am proposing is maybe it is time to actually adopt this into a standard. So if you adopt this into a standard, then people will start generating these images like so, because it has got the OCI blessing. But yes, so you have, in this case, you have vnd.erofs, maybe it is vnd.oci.erofs or something. So
Yeah, what I was curious about is there's a weird like it is ArrowFS and SquashFS, but on the first layer it's kind of pure. On the second and third layer, they're ArrowFS or SquashFS plus overlay metadata. That's like, it's kind of like they don't stand on their own. They have some other aspect to them. So I wonder, like, if we need, or if we can just use, like, for the first layer, have it just be the default, but then, or just have it be the pure definition for SquashFS or ArrowFS. But then for diff layers, actually define them as like an overlay diff, because they include metadata that, like, it's very specific to overlay. Like, you couldn't use it for any other sort of mounting, or if you wanted to use it for something else, you would have to decode that overlay data.
which is probably less of a problem as of now, because everybody's doing overlay, but if it moves to something else, then we have a problem.
Oh, I'm not suggesting moving away from overlay. I'm just suggesting that data should be encoded as this is ArrowFS of an overlay directory, or SquashFS of an overlay. But the first layer is not. The first layer is just a pure file system. Like, there's no overlay data that ever gets written to the first layer.
The other thing I would like to point out is, of course, these media types can be a mix and match. We should also take into account those cases, because if you want images to be compatible with the rest of the universe, not everybody is going to. You have the legacy images, you have the new images, maybe mixed images, and so on and so forth. So this could be a SquashFS, this could be an EROFS, it could be a TARFS. So all of that is possible, I would imagine. So there is that additional headache to take care of.
Well, yeah, mixing like Arrow and Squash probably wouldn't. Well, I guess it'd be fine. It's how you, once they get looped back.
Yeah, overlay should take care of that, hopefully.
Yeah, once they get overlaid. I'm thinking from the perspective of on how we might handle that on Containerd, but maybe we don't care too much as long as we know what the mount is for the mount call for a specific layer. Yeah, because like today in Containerd, we have in our structure where you could return multiple mounts, but the reality is that we don't actually support that. So we're trying to actually add support for that. So like the mount call would look like you have essentially 4 mounts for this, because you have 3 loopbacks and then a overlay. But obviously, like, they have to be stitched together, because the output of one goes into the input of the other, or the last one. So that's kind of what we're trying to figure out there. But yeah, it doesn't actually matter individually what those layers, how those are mounted. Like, some of them could be lazy loaded, some of them could be on disk. Yeah, it doesn't matter. The DM Verity stuff, I think that's an interesting part of it. Is that something that you're adding, or you said it's actually built into SquashFS?
Yeah, no, this is a, one second. So there is a, So there is a tool like this, right? So if you take a look at this, again, all of this is built as libraries into the squashers, but the concept is this. So once you build the squashfs file, then you basically do this. So you build your hashes and give it an offset at the end of this file. So it is a separate step when generating the image.
But you don't have to have that offset mentioned in the metadata there?
Probably not, because you know the size of the file system of squashfs, and then DMVerity is probably going to figure it out at the end.
I guess what I was trying to think of is for the lazy load case, we want this metadata. We want to be able to use that up front, or basically be able to go and reference each individual block by that hash. And then that hash is going to translate to an offset that we go and query the registry. And then obviously the result from the registry, we're going to get back verified against that hash for when we actually deliver that. I was just curious if DMVerity, the hash that it gives us, besides just verifying the single hash at the end, actually has that support.
It does. So DMVerity, so basically it does a block level hash, and then you hash the hash. So that's how it's a Merkle tree really at the end of the day. But the requirement that maybe you want to take a look at these hashes while it is downloading, or while it is without waiting for the whole thing to end, as it is done now, maybe that needs a change.
Yeah, and then the corollary to that would be, do we want to just define a way where we just use that hash up front? So the concern being that if you the point of the system is content addressability, meaning the hash that we're verifying is the hash that we use to fetch the content. If we have a secondary hash, that's great, but then we still are stuck in a situation where we have to pull the whole content down before we can verify the content hash. Whereas, say, the DMVerity hash is the first hash that we reference from the registry. Then we could basically pull each block and verify it along. We could basically verify it along the way without having to have any extra part of the lookup for like the Merkle tree lookup. If that makes sense. I don't think that made sense, but the idea is that the same hash that we actually use to verify the content is the hash that we use to fetch the content.
So what are you thinking? We could relax the hash check for certain cases where, for example, on the artifacts or an image that we're loading for a pod, it's not not runnable, read-only kind of thing or something?
I'm saying we don't want to relax the hash check. Ideally, what we do is the first thing we download is, say in this case, the DMVerity info, verify that first, and then go and fetch each individual block. As soon as we have verified a hash, then we can go and fetch. Then we can start using the file system essentially. So let me just put it that way. If as soon as we have a hash that we have verified, then we can use the file system. If that hash is the whole file, potentially large file, then we can't use the file system until we've downloaded that whole file. So the DMVerity, in theory, gives us the ability to start using that file system earlier, if that's the first thing that we're fetching.
Right.
The impression I get is you're going toward lazy checking of the hashes instead of doing one big check all up front.
Well, it's not lazy checking, it's block level checking. It's you're checking the blocks up front. The DMVerity will give you the hash that includes the hash. I mean, it's a Merkle tree in of itself. It's basically verifying every block underneath it. And then you can go and verify.
Yeah,
each
that's
individual
fair,
block.
as long as each block was verified, I think that's a valid scenario. Right? The only risk there would be you might have to abort the process if a page doesn't match. Right?
When does that check run? And the direction I'm going with that is it at time of use or is it at time of unpack or load or whatever? Like if you were to do a read on the file system, would that file system read suddenly come back and say failed because the Verity check failed? Or would you know that as soon as you unpack the container image and said, let me start up this container? Did that question make sense?
Question to Rom.
Rom, do you
It
happen to
is
know
when
that?
you, yes, it is when you, so you get this blob and you do a DM Verity check on it, and then you, so there is a, in Linux, you have the device mapper, right? So you can actually do a device map on this layer with Verity enabled using DM Verity. So you would want, so the way at least we have it internally is we download the blob, we mount it as a device mapper rather than a plain squash FS. And then those device mapper mounts, you mount it via overlay mount. So that way, those are the steps.
And so
Which is,
when you say that you're going to do DM Verity on the device mapper, does that then do an immediate scan of the entire device mapper file
yes,
system that you've got there and check every block at that point? Or does it configure device mapper to know that, hey, as I access this data, if anything ever goes wrong trying to access the data at runtime on the fly, then I fail. You know, it's when does the error get triggered is
okay, but yeah. So whether it is an early check or a lazy check, that's the question, right? So I don't know the details that I can get back.
That's in the kernel though, right?
Yes, it's in the kernel.
Yeah, I'm looking for whether the mount will fail or whether the read within a mount is going to fail.
Got it. Yeah, that's the implication. Yeah,
Like
I
if
can
it's a kernel, it's
check.
probably lazy, but which is I guess there's two aspects of it. One is that's great to have that even if it's a lazy check's better actually in that case because it wouldn't cause any slowness on startup. That's great to have, but we also want to verify everything at pull time. So if we have the Verity check at runtime, great, like we want that. But the pull time, if we have to download the full object, so ideally it's just we could just use one hash. But yeah, I think the way it is now, you'd have to download, basically verify the whole thing before you even can start using it, before you would even want to call them out.
Yeah, I would say pro and a con to each side of that. I don't think there's one side that's good or bad. I think they just have trade-offs.
Panic. Yeah, that's like I've already verified this and something manipulated it and I just want to panic.
And that's panic the entire kernel. That's not panic the process.
Yeah, that's an option. I think you can set it. You can set up your Verity blocks to give all this advice. I guess.
Which is
with
fine if you've
upstream
already
user data-
verified it.
Yeah.
If you verified it, then corruption really means corruption. But
at the device level or something like that, you know,
but
there's something wrong with your
corruption
hardware.
at the distribution level should be par for the course, or at least like
You don't want a malicious image panicking your kernels.
Yeah, exactly.
But that does imply that it's doing checks as it's reading the files. I don't know if it's both or not, or if there's the option to do both.
Yeah, that's all I had about this.
One quick thing, and that DM Verity hash is also built into the file.
into that blob. Yes.
Okay. Because yeah, I saw there's a label there, but is that label actually used for anything right now?
Let me check. This one?
Yeah. Like, do you
It's
have to give it on the mount option or anything?
I don't think so. This is just something that this just metadata that we added. So
It feels like it would be something good to be able to inject.
yeah. Let me get back to you on this as well. Yeah, these are details that I don't interact with on a daily basis, but let me get back to you on this also.
Yeah, I was just curious if
Because
any
you
of
do
these.
need, yeah, you see, at the end of the day, you still need a hash to say at the production time, when you produce this image, this is the hash I made. And when you distribute it and gets corrupted on the fly, this is just a hash. Then how do you catch it? So I think that's what this is used for.
It reminds me a lot of the Sochi, where Sochi was including the hash of the table of contents. That way you could start doing that lazy loading of those hashes without needing to verify the digest the overall blob. Cool.
Anyways, yeah, I
Should
think
we-
it looks good. We want to move on to another topic.
Yeah, I'm ready to jump onto a different one. Rom, can I switch to screen share?
Yes, please.
So we had a couple of others. Real quick. This one maybe would be a little bit of discussion. So before I circle back to this, that was on image spec. I just wanted to point out that ROM's PR is sitting out here, and we've got a couple maintainers around that might want to review it for the content range request.
Yeah, I just took a look at it. I think the latest version is simple and looks good.
Yeah,
I'll put that
streamline
in.
the text down to just saying, point to the RFC and please support that if we could.
Yeah, so if anybody needs a sample code on what I'm testing, of course it won't pass any coding interviews, but yes, I can show you that also. So just to test that.
Would any of our stuff pass a coding interview? I know mine would. All right, so I just wanted to raise some visibility on that one because I think that's an easy merge there. And so with the last few minutes, the other one I wanted to circle back on, I've been having this conversation in a few different places, has been the KEP out there that's talking about adding the OCI as a volume source that they're talking about in the Kubernetes land. It feels like something that would make a lot of sense at a higher level in Kubernetes, or at a lower level, depending on which way you draw your trees. Something that container
Define
D.
higher level. You mean
Yes.
CSI?
Something that container D, something that Docker, something that Singularity, whoever is doing these kind of tools where they're writing stuff that is running container images might be interested to do it so that it's not Kubernetes specific.
Yeah, I think the trick though was that it's for a shared set of containers. We don't have a pod spec. I think we probably would benefit from having a sandbox spec in OCI. Or
Yeah, we definitely have a gap between the image and the runtime, and so this might be another one of those things that's falling in there.
Yeah, Derek, I don't know if you've seen this. It's fairly interesting. They're asking for a particular pod to be able to specify an OCI image that you can pull down that's read only, and then we should be able to share it across a set of containers. We can pretty much do that already without using the infrastructure with the volume. If you were to write your own CSI driver, but this is trying to clean it up and make it easier for the user to say, I want to pull this image and mount it, for all these containers, or at least for a set of containers that has a path map to it.
Yeah, I don't think there's anything in core containerd that makes this a challenge to do.
Yeah, I don't think so either. Yeah, should be
Like,
easy.
I think we mostly have those abilities already.
Yeah, it's just a matter on Run Pod Sandbox, we'd go ahead and pull that image and, as well as the pause, and then we would set it up as a mount.
Ooh, that's a question though. Is that image not something that the kubelet would explicitly pull and manage?
Well, they would ask us to pull it, and then when they run Pod Sandbox, they would have to tell us that they want this to be mounted. We don't right now in pull image have the ability to pass them the path of a root FS mountable, for the image, mount for the image. We don't really tell them that. We just say, yeah, we've pulled it.
Well, they don't need the
want
path.
the
They,
kubelet- Sorry, I think we would want the kubelet to still do image management. So be responsible for telling Containerd to pull it, pass credentials, do garbage collection, all of those the same things that it does for regular images today.
Yeah.
yep.
And
I
it's
think
for a particular pod, yeah. Just as it is today for a runtime handler. So we can handle this in, confidential computing and whatnot.
yeah, for Containerd, it should just be we just create a view of it, add the target to whatever they say, and then maybe add a label to link to it, and it's easy.
Yeah.
Does that mean
Yeah,
extending?
label annotation on the image would work so that when they get a list, they'd see it, and get status on the image, they'd see it. That makes sense.
Would that be involve extending like the CRI or something over there for the kubelet to talk to Containerd?
Yeah, that's what we're talking about. When they call status on an image, it's through the CRI.
So where does OCI fit in?
Well, OCI would fit in if we said this is really cool if it's a Kubernetes only feature, but what if it's not Kubernetes only? What if we want to support this for running local Docker development? What if we want to support this for spinning up something in one of the various cloud container sandbox runners out there that exist?
Yeah, there's two parts to this. One part of it was that this request was originally just for artifacts, and then they changed their mind and said artifacts were image, and it looks like image would be easier, of course. But yeah, and we're also talking about data only images, which I know Docker originally had a version of that, but we sort of backed off, right?
Well, the data containers back in the day were kind of sunset for the concept of just using a volume.
Right. Which is different, right? So I guess for these images, there would be a config and possibly it could be runnable, but we're deciding for this particular purpose, we're only going to mount it read only and not, not actually attach a command or run anything in it or allow it to be runnable.
Yeah, the initial design they're asking for is let's use the standard OCI layered file system image format that we have for container images. But there are a lot of people saying, what about an artifact in terms of if I want to mount in a machine learning model that's just packaged as a binary as a label, as a layer, and not put inside the tar-gz syntax.
Right. And then I think that's where it gets a little tricky because we'd have to have some kind of a config for each type to, parlay, if you will, what is this type? How do we actually make a file path for it? Something mountable. What if it's just config only? Are they, does that, if it's an SBOM, or do they really want this to happen?
What if you have multiple files in the same image too? You've got multiple layers. That could be multiple files and they're all mounted separately.
Exactly.
What would be your proposal for where this would fit into the OCI image spec though? Because I know it's like Helm charts, for example, had some similar things with linking images together, but it's tricky business from the way we reference images because we just try to reference just the objects and that we're going to go fetch, but as soon as you link an image to an image, then you have to deal with weird versioning issues and are you paying it to a digest? And is that what a user really wants?
I think where Mike was kind of right there was saying that there's a point between image and runtime that we have not defined. So pod spec and whatnot is not defined within OCI, but I wonder if we're finding another one of those points where it could be aided if we had some kind of way to do some standards in there somehow.
Yep.
But as Jory points out, we are at the top of the hour.
Brandon, you'd said, oh, a lot of times we don't have much to discuss, but you always use the full hour. It's always really interesting and in-depth conversation. So clearly you use the time very well.
We do like to chat. We're a social bunch. And we haven't strangled each other physically yet.
No fisticuffs. That's good.
We should add this as a discussion, maybe next week, Brendan, to talk more about what would it look like, right? I think it would be similar to just my internal thoughts here is that like we do platforms today, Kubernetes is a platform for pod spec, right? So we could have a subset where we're just saying, there's a concept beyond index where you would have a index of images that are associated with each other from an isolation perspective, defined by a particular platform type, for example, Kubernetes.
Yeah. As we start getting into trying to map those gap or try to bridge that gap, we might want to start engaging some of the runtime spec maintainers as well to see what they have to say.
Exactly. Yeah.
All right. At the top of the hour here, past the top of the hour, people are dropping like flies here. So I'm going to go ahead and call it in. We'll restart next week.
See you guys.
Thanks, everybody.